Hello students, in this class we will be studying about 1 Newton, spring force, impulsive force. Impulsive of a force is equal to change of momentum of a body and Newton's third law of motion from chapter Laws of Motion. 1 Newton. What is this 1 Newton? 1 Newton can be defined as that force which acting on a body of mass 1 kg produces an acceleration of 1 meter per second square. You can see in the diagram that a body of mass 1 kg, a force is acting on that body and produces an acceleration of 1 meter per second square. Next comes spring force. What is the spring force? You have all played with the spring by compressing it and leaving it. What happens when you compress and leave the spring? It regains to its original shape. It tries to regain in its original shape. So we define that the restoring force developed in the spring when it is stretched or compressed is called spring force. In a mathematical form, a spring force can be written as F is equal to minus kx. K is called spring constant or force constant and x is the change in the length of the spring. You can also note that the unit of the spring constant is Newton per meter. Spring constant is defined as a spring force required per unit stretch or compression of the spring. The negative sign of the K is indicating the restoring force in opposite to the extension or displacement of the spring. Now we'll study about impulsive force. Large force acting on a body for a short interval of time is called impulsive force. Look, when a ball is kicked in a short interval of time, a large force is acted on that ball. Similarly, when a nail is hammered in a short interval of time, a large force is acted on that nail by the hammer. The other examples like striking a cricket ball, of kicking football, etc. You can still list many of the examples of impulsive force. Now we'll define impulsive of a force. The product of average force and time for which it acts on a body is called impulsive of a force. Now we'll study impulsive of a force is equal to change of momentum of a body. From the examination point of view, they might ask you, show that the impulsive of a force is equal to change of momentum of a body. Now let us start. Let a force F acting on a body of mass m for a short interval of time t. Impulsive of a force J can be written as average product of force and time. So from Newton's second law, we can write that F is equal to ma. Now the equation becomes J is equal to ma t. Now from the equation of motion, we can write A is equal to V minus U by T. What happens next? J is equal to mv minus mu, which is change in the momentum. So we can show that impulsive of a force is equal to change of momentum of a body. Let's state Newton's third law of motion. For every action, there is an equal and opposite reaction. Let's try to understand. Let FAB be the force exerted by a body A on a body B. FBA be the force exerted by a body B on a body A. Then FAB is called action and FBA is called reaction, such that FAB is equal to minus FBA. Some important notes for Newton's third law of motion is action and reaction are nothing but force. Force always occurs in pair. FAB is equal to minus FBA. That is, force on A by B is equal to negative force on B by A. The force on A by B and the force on B by A act at the same instant. Action and reaction force act on a different bodies and not on the same body. Here are some of the examples of Newton's third law. While swimming, we push the water back and we go front. While we go front is nothing but the reaction, and while we push the water back is nothing but the action. The second example is that a bird is flying. It pushes the air downwards with the help of its wing, and the air pushes the bird upwards. That is the reaction, and the wings which are pushing the air down is the action. Another simple example is that when you throw a ball to the wall, that is the action. With the same force the ball comes back to you, that is nothing but the reaction. I request you to list some more examples on Newton's third law of motion. In the next class, we'll study about law of conservation of momentum. Thank you.